Good morning, friends. This video is going to be about solving equations using inverse operations. There's some important vocabulary on this page, so if you haven't had a chance to review the vocabulary yet, it's important that you understand that an equation is something that sets two values equal, and that inverse is the mathematical opposite. So the inverse of addition is subtraction. The inverse of multiplication is division. Okay, so these are the inverses. So sort of undoing the operation. In the order of operations itself, right, GEMDAS, the order that we usually do our operations is, if we're doing the inverse, it means we're doing the backwards order of operations. We're undoing, or I like to think of it as unwrapping a present. When we wrap a present, we put the paper around it first, and then we tape it, and then we put a bow around the outside. And when we unwrap it, we do it in the opposite order. We take the bow off, we take the tape off, and then we unwrap the paper. So if you're working through GEMDAS to go forward, backwards, the order of operations is SADMEG, where S and A are subtraction and addition, which are inverses. D and M are division and multiplication, which are inverses. And then we have exponents and grouping, which we will actually deal with later on in our solving. So I'm not super concerned about those right now. So we'll talk about those more in the future. So the most important thing to get used to with writing equations is this shift in mentality, or this shift in thinking. It's not as much about finding the answer as it is about showing your steps and explaining your logic, the reasoning that you're taking each step along the way. And the reason for that is because algebra is a method or a system of sort of untangling these equations. And as we build further into algebra, we're going to put more and more and more steps into the equations that we're going to untangle. So getting good at using the steps in order and logically will help us build to further equations. Whereas if we're just trying to guess and check for the answer, if we're just trying to put in numbers until we figure out what works, that system is going to become less and less efficient as we move into more interesting problems down the road. Okay, so with that in mind, I'm going to really think about a couple of these pieces. So I'm going to think about using my inverse order of operations. And I'm going to check first in this equation. I like to read it first to myself. So here we have negative 92 is equal to negative 9 times n plus 7. So if I'm the n, if I'm the unknown, I'm being multiplied by negative 9 and then added by 7. So the n is being multiplied and then added. So looking over here at SADMEG, I'm looking for an instance where something is being added or subtracted to my unknown. And in fact, the 7, right, is being added to the unknown, right? Negative 9 is multiplying the n, but the 7 is adding the n. So I'm going to do the inverse. So the inverse of adding 7, right, the opposite of that is subtracting 7. So lined up right underneath this plus 7, I'm going to write minus 7. I'm going to take 7 away from this side. And then whatever I do to one side of this equation, right, because this is like our balance, whatever I do to one side of this equation, I have to do the same thing on the other side. So I'm going to line up this negative 7 with the negative 92, right? They're like terms. You can go ahead and add them. Notice the negative 9n is not like terms, so we wouldn't be able to, well, anyway, so that's interesting, I think. So negative 92 minus 7 more will give me negative 99. equals. The equal sign stays right on that central line. I can bring that central line down a little bit further. This negative 9n, I didn't do anything to it. I'm not adding or subtracting anything to it. It's not changing. So it just drops straight down. And then this, if I have positive 7 and I take away 7, if I have 7 apples, I take away 7 apples, they cancel out, right? So there's nothing remaining there in that space. So now I can look at my new equation, right? My next equation is now that negative 99 is equal to negative 9 times n. So this is sort of like a simplified version of that first equation. So I go back to my unknown. If I'm n, what's happening to me? Well, I'm being multiplied by negative 9. So the opposite of multiplying something by negative 9, or the inverse of multiplying something by negative 9, the inverse of multiplication is division. And we're going to divide by the exact same number that was multiplied by. So I'm going to divide by negative 9. So the way that I write that is I like to write it with a fraction bar. Divide by negative 9. Divide by negative 9. So on this side, if I divide negative 9 by negative 9, those cancel out. And all that I have left on this side is n. N is equal to negative 99 divided by negative 9. So a negative divided by negative is going to be a positive, and 99 divided by 9 is 11. So my answer is 11 equals n. Now the nice thing about equations is that I can check all my answers myself. I don't need to rely on a textbook or a teacher or somebody else to tell me whether I'm right or not. So I'm going to go back up to the original problem. I'm just going to rewrite the original problem. Negative 9n plus 7. And now I'm going to take my answer that I got, my positive 11, and I'm going to plug it in for my unknown. Remember to use parentheses because we're multiplying. So I'm going to say negative 92 maybe, I'm wondering whether it is, equal to negative 9 times 11 plus 7. So now I'm going to just simplify this right-hand side first, right? I'm going to leave the 92 by itself. I'm just going to simplify this side and see what I get. So that may be equal to negative 9 times 11 is negative 99 plus 7. And negative 99 plus 7 is equal to negative 92. So look at that. Negative 92 is in fact equal to negative 92. The problem checks out. Let's take a look at one more kind of problem. Okay. So again, we're going to read the problem, figure out what's happening to it, and then use our order of operations backwards to solve. So 15 is equal to 9 plus n divided by 3. So if I'm n, if I'm an unknown, I'm getting divided by 3, and then I'm being added to 9. Okay, so the opposite of adding this positive 9, the opposite of positive 9, or the inverse of positive 9, is subtracting 9. So lined up with that 9, I'm going to subtract 9. Whatever I do to one side, I'm going to do to the other side. I'm going to drop down what's left here, because 9 minus 9 is 0, so that cancels out. So I have n divided by 3 is equal to 15 minus 9, that's 6. And now I'm going to undo division. So the opposite of dividing by 3 is multiplying by 3. So on this side, I'm going to do a multiplication. I'm going to use a multiplication dot so I don't get confused, or I might even want to use parentheses. And I'm going to multiply by 3. And on this side, I'm going to do the same thing. I'm going to multiply by 3. Now I might want to think of this as 3 over 1, so I can think of this as what happens if I have n divided by 3 times 3 divided by 1, right? Look at these fractions. I can cross cancel those 3's down to 1. And what I'm left with on this side is just n is equal to 3 times 6, which is 18. Now I can check that by plugging it back in. So 15 is equal to 9 plus n divided by 3, which means, let's check, is 15 equal to 9 plus 18 divided by 3? Is that equal to 9 plus 18 divided by 3 is 6, is equal to 15? It checks out, and so I know that this answer was correct. Okay. So for homework, try the 4 problems that I've posted, or maybe I'm using this for future years, so however many problems I decided to post. And come to class ready to ask some good questions and explain your reasoning. Thanks so much.